shorter than the vectors to the center, now the geometry explode, is still no equilibrium. So what would happen is that you would have to make sure that the geometry's edge vector and vectors to the center are the same length. And the only geometry in which this happens is like the snow crystals, the hexagon, where the edge vectors are the exact same length as the vectors to the center. And if we made a 3D hexagon together, we would get a vector equilibrium, which is made out of 12 vectors radiating from the center and 12 edge-bounded vectors that maintains the structure in perfect equilibrium, or 8 tetrahedrons coming together, all right, to create, a vector equilibrium. So 8 of these coming together to create a vector equilibrium. And so that was really telling. That was really exciting for me. I knew this had to do with what I would have to deal with even if you think in advanced physics, for the physicists here, that, of the structure of space, you could think that the vacuum state is going to infinity. At one point, it would have to reduce to the minimum amount of vector for stability. And that would be 12 vectors. So that's the fundamental, basic geometry of equilibrium. But it actually didn't fully work. That is, I still had points on the edge of my metric here, right? I still had vertices on the edge of my metric that had holes in it, right? So there was a symmetry. This middle structure with the 2 isotropic vector metric was completely filled, but the edge was not. So I had still asymmetry. I still didn't have equilibrium. So I started scratching my head some more, and I thought about it, and I thought, okay, well, my only solution is to continue to add tetrahedrons until I get equilibrium at all levels. So I continued to add tetrahedrons. I covered the spaces that were open on the edge of the metric. So I had to add 3 tetrahedrons to every edge, which was 8. So that generated 24 more tetrahedrons. So remember, there's 20 tetrahedron in one isotropic vector metric. 2 makes it 40, plus 24, added up to 64 tetrahedron grid. And that, when it came to me. At 64, it all came together. Why is that? Because when I put those added 24 tetrahedron in my head as I was visualizing all this in my van, I realized what I had done. I realized that I had generated a vector equilibrium in the middle, but now I had generated a larger fractal vector equilibrium on the edge. And so now I had a metric that was growing from one vector equilibrium to the other, to the other, to the other. And interestingly, they grew in perfect scale of exactly half the radius, so in harmonic scales or in octaves, if you want. And it was a 3-dimensional fractal. This is actually one of the only true 3-dimensional fractal I believe exists. And it grew radially, which is what I needed for the radiation part. And then I realized something even more significant, is that the fractal growth could be generated from 8 star tetrahedron. So 1 star tetrahedron is 8 tetrahedrons coming together to make an octahedron in the middle. Everybody sees that? 8-star tetrahedron, 8 stars like that, coming together, okay, to create the vector equilibrium. Right? So 8 of these coming together to create the vector equilibrium. And when I realized that, I saw that the star tetrahedron is 8 tetrahedron pointing out, and that the vector equilibrium is 8 pointing in. And now I had both sides of the event horizon, the radiative side and the contractive side, all in one mathematical metric that was producing both to generate the feedback of creation. I was really excited then. I mean, people would, anyway. My van was bumping around, and it's not because I had a girlfriend. And so so I realized this, and it was like the 8-star tetrahedrons coming together to create the vector equilibrium in the middle. Just like this. And when the whole thing was put together, it would generate a vector equilibrium in the middle, right? The vector equilibrium in the middle. And then it would generate the next fractal vector equilibrium on the outside, right? And so it was a radial growth generating scale in the vacuum. So I was really excited. I thought I found something very significant. I was looking now to solve this and in terms of physics. How does it apply? How does it, emerge in the physics? And as well, I was starting to think, well, this physics must have, angular momentum, must have dynamics to it. This is not a static thing. This is a fluctuating thing. So how does that all compute? And, I was doing research in advanced physics and all this. I came across a graphic on the internet of a phenomenon that's called crop circles. And that graphic was a perfect representation of the fractal structure of space I had just described and found in my van jumping around. Now I know that there is hoaxes out there and hoaxers out there, and I know they make crop circles at night with their gumboots and drinking moonshine and stuff. But there is as well a lot of genuine phenomenons that goes on with these crop circles, where it's not obvious to just write it off as people jumping around with gumboots. Or Doug and Dave out there, having a good time. What got me really interested is that there was a bunch of croppies, people that photographed these things and measured them and all this, that had gone into, they figured out if somebody is trying to talk to us, whoever that is, maybe we should just try to talk back. So they got some gumboots and they went in there and they stomped around in big letters in their field. What do we need to know? And the very next crop circle that came out was this. And that really, struck a chord with me. And if you look carefully, you can see that the way the crops was laid, it made an effect of light and shadow in which you could see the vectors of the tetrahedron that would be creating this metric in three-dimensional space. Now that's not obvious to do in the middle of the night, in the middle of a field. All right? This is not a small thing. It's a large thing, and it's very, very accurate. And then a few weeks later, they seem to insist on the pattern. Another one, just like the first one. And this one with another set of information in the middle. In this